Good morning, we're at EMO Hanover and I'm here at GROB. This is a massive stand with a lot of technology and I'm here with Tobias that is going to show us just a little bit of what they have here. Hi Tobias, how are you?
Hey Ferry, I'm wonderful. How about yourself?
Pretty good, pretty excited for being here and to learn more about GROB's technology.
Yes.
Tell me, what do we have here?
Here we have the GROB automation cell. That means the GROB robot cell, which can make lots of different applications tailor-made to the customer, where we're loading from a shelf, either raw material, vices, or even pallets with vices on top and even workpieces. And this allows us lots of combination, which we usually have been asked by the customer. So you can see on the side, if you're capturing inside, we even have a pallet pool where we can store the gripper fingers, so a gripper area for having all these different vices for loading and unloading.
How many grippers can we have in here?
On this cell we have a place for storing 4 grippers, which is more than enough for handling vices, pallets or raw material.
And we can also have a pallet pool in here, right?
Exactly, a pallet pool is inside for storing pallets with vices or fixturing. That's all available.
And how many pallet pools can we have in here?
We have a whole rack,
okay.
So you can have up to 40, 50 pallets, depends on what is the size and height of the pallets itself.
And this is all, we can make it custom to the client, right?
Absolutely, it's like, I would say, it's like a Lego platform, so we can do lots of different configurations out of a modular system, so whatever the customer is asking us to get, that's what we can provide.
And this is the biggest size of this model?
This one, yes.
And do you have a small one?
For sure. We have the smaller one on the other side here, which is the GRC-R12.
Okay.
So the GROB robot cell with a robot that can lift up to 12 kilograms. The concept is equally like the big one. This is only for smaller applications like medical industry, for example.
And it has the same, like the grippers, the pallet pool, the same but just smaller.
Exactly, majorly the same features, slightly less because on the smaller area you don't need all of these features, but yeah, for sure you also have a shelf for raw material. You can put the raw material in and even have a blow box or stuff like that.
And these two, like the small one and the GRC, the big one, they are new releases from EMO.
Exactly, that's the latest development which we are showing here with lots of features which we haven't had before. So this is really the latest update that we can provide.
Can you just give me a little bit of what is new in these equipment, like that you didn't have in the last models?
The latest is really the flexibility of combining all of those features, okay, that really we can tailor-made but also have it out of the modular system, so we don't have to invent it every time, which makes it more easier and more cheaper for us in the end, which is the benefit for the customer.
Yeah, that's great. What do we have right here? Oh, I saw before like a car moving.
Yes, the car is just standing on the corner and sleeping, so it's just loading for the moment. Here we have an AGV. It's an autonomous driving vehicle. It's guided by itself, and we here for loading and unloading pallets, as well as vices, for making sure the machines, even if you have a standalone system in your manufacturing, it can be combined with other cells. It can also load and unload tools, or even load and unload the chip conveyor.
Okay. Can we like combine this system with the system we see before?
Exactly, you can combine all of those systems. It's a standardized interface, like you see the orange gate, and this makes it possible to interact with each other.
It's amazing how much we can automate our plant right now.
Now you can see it moving, exactly.
It's awake.
Now it's awake, yeah. It's recharged for doing more work.
Also, now that we're here, I see that you have a lot of applications.
Yes, we're also serving a lot of branches, as you can see, the automotive industry, mechanical industry, medical, aerospace, mold and die. So all of those different areas and branches is what we are serving into the market, where we can do applications, where we really know what our customer are requiring. So this is really a key point.
Yeah, you serve all the industry basically.
Exactly.
Hey! What's this?
This is this is a VR glass. That is something that we can use, for example, for trained people, specifically in the electromobility, where we have so many different stations which are doing a rotor, starter, hairpinning, all of this very complex components, you can imagine, never ever. We have all the stations on site, yes, when the maintenance team or the operators are on site, and to teach them, that's what we're doing with this VR glasses. So he's actually seeing one of those cells. He can step in the cell. He has two visors where he can click on certain features. He gets some information, training, news, and even videos can be played. Yeah.
That's so cool because it makes training and education way easier than
Absolutely,
before.
absolutely. You can just send around this kind of glasses all around the world, and you don't have to fly hundreds of tons of material around the world.
To get this training, just the glasses, that's amazing.
Exactly.
What's
If we come in around the corner here, this is our demonstrator. So
cool.
as we just spoke about all these different features that we can use for the VR glasses, here you see how the outcome is in the end if you put all of those features together that we can machine. So you see here a rotender starter, like the engine, the electrical engine of an electrical car. That is something the camera can also capture on the left-hand side. That is how it looks like from the inside. You see the pin, that is an hairpin, so-called, and we stick those in the metal sheet, and this becomes the engine in the end. If you fire them with electricity, it pushes the car forward. What we do further is all the sheet metal machining. We're coming to this machine later, but also we are very well known and producing battery cells. So it's an anode and a cathode. There's an isolation sheet in between. We're folding all of this, a bunch of them getting glued together for this kind of cell. As you can see, it's a very thin one. You have two sides where you can get the current in and out in the end, and a couple of those becoming a pack. Those packs will be then racked here in the big portion, and the whole frame in the end is below your car, and that is actually the whole battery that gives the energy to the engine to push the car further. All the other components, which you can see here,
can be made with GROB machines.
We can do this with GROB machines as well. We machining them. That is what we do on a system, on universal machines. So all these components, what you can actually see is something, if you want to do a one-stop shopping, you can do this at GROB. We're providing the production lines for all of those.
That's amazing. Like one-stop shopping is the best thing. Like you only deal with one person, with one company, and I mean the training that you're giving with VR and everything. That's so amazing. We're getting here to digitalization, right?
Exactly, that is digitalization, and here actually we're using our artificial intelligence. So there's a lot of systems around, but here we have a key feature that we're using. So you can actually punch an icon and start recording. So the voice will translate it to a question to our artificial intelligence. And so, for example, you can ask, where do I find, for example, this kind of tool? And usually it's only recognized by the system itself as long as it's in the shelf.
Okay.
But if you put it in a machine, it doesn't know where it is in the machine, or even if you know it, but it maybe don't know right on this very moment, how is the tool live? So to really making sure we're getting this information, that's where we're using this artificial intelligence, because it collects all the details of all running machines, which we can combining, and out of this, it will give you the answer where you find this kind of tool. For example, here we were looking on a special milling tool, diameter 10, and even it tells us we have 3 of them available in those 3 machines with a remaining tool time. So it's very cool if I'm looking for where do I get this kind of tool already equipped just for the next job.
And for example, all this information we get it like in the computer, but is that a phone we can get it like in our phone as well or something?
Sure, we can transfer this to different mobile devices, so either a cell phone, a tablet, or even if you're sitting in the office, you can also have it on your screen.
Yep, so if we're done in the office and we go home, we can still like check in our machines and ask all these questions we get.
You can sit on a couch in the evening and still checking what the performance, for example, of all the machines is, where the logistic of the tools are. Exactly, you can check all of this out.
That's great. It's great to have all this information like in your hand at any moment.
Absolutely, absolutely.
So, we're getting to the big machines here.
Exactly, yeah. So this is a G720F machine. So it means size-wise, we are talking here about 7. So we started with a G350 and a 150. This is a 7 twin spindle machine. So we have 2 spindles working simultaneously. And as you see, we have a bridge. On the bridge, we have 2 times working areas where we have 2 work pieces. And those pieces are for the car we just saw in the entrance, exactly. So what we can do here about gigafactoring parts in regards of gigacasting, big frames, battery housing, stuff like that, which we are using for bringing the electricity into the car in the end.
Like, which materials can we working here?
Mainly aluminium. That is mainly how such kind of parts are made out of. For sure, there's also possibility of work with this kind of machine with steel. That's also possible, but mainly it's aluminium, what such kind of parts are out.
And we can combine like these machines with the first automation cells we saw before and the VR.
Exactly, we can also integrate them and loading system, implement them in a production line. All of those is possible out of one hand, out of GROB, yeah.
So, going next, we have additive manufacturing. I really love this topic.
Yeah, this is our GMP 300, the GROB metal printing machine, which consequently, as you can see here, we majorly printing aluminium. So we have a kind of a pot. In the pot, we have an aluminium wire, which you can see over there. And the wire gets into the pot. The pot is heated, so the aluminium becomes liquid, like on Sylvester, when you do the aluminium sparkling.
Yeah.
And then we have a pin inside, and the frequency and the length of the up and downs, we generate drops which are coming out here. And these drops are on the machine, will be will be printing all of those different features. So like a wrench, which you can see over here, different other parts, structure parts for cooling down certain components. So lots of different features are able.
And can we actually use these parts like in a job, or there are mostly prototypes?
No, this are for sure you can use it for prototyping, but we're learning more and more that this is really application which if you have small batch sizes, it makes more sense to print them in this way, specifically if you have special features like you have holes which going inside on a mechanical way. You would not be able to machine a component like this. The same if you go in different parts, sometimes you don't need the high accuracy, but you just need a function behind this to fix something or to hold something. And maybe, let's say, on a ship or some certain spaces where you don't have so much infrastructure, such kind of machine is easy to allocate, and then you can get all the work pieces you need.
And how fast can we have like these kind of pieces? I mean, I know it depends on the size and the complexity.
Yes, exactly. That's right. So, as I said, what we're doing here is liquid metal printing. So one drop goes on the next. It's not powder bed.
Yep.
Powder bed, I think everybody knows more or less about the speed.
Yep.
With this technology, we are between 5 and 10 times faster than powder bed machining.
That's awesome.
And the difference comes from how accurate we are. So we can make up to 5 micron big bubbles. Then we need more time, but it's very accurate. On the other side, if we print with very big drops, we are up to 10 times faster. You see a little bit the difference here. This is printed with very big bubbles.
And that make it less precise. Like when
less precise,
the
but
drops are
faster.
Bigger,
Exactly.
Okay.
And here on the other side, it more precise, smaller pieces, so more accurate. You can see that if you look on the finish, exactly. This always is in regards what the customers require. But the good thing is, we can, let's say, on the outside, we could say we make a little small bubble. In the inside, where it's only to fill it up, we make big one. Then we still have a very high accuracy in the outside, but to fill it up is quite fast.
It's just that we can like mix like the small bubble and the big one. That's
exactly.
Great.
It's a continuously process, so it's very easy. It's just a parameter that we can, from bubble to bubble, adjust. So it's really easy.
Tobias, where can we see all this technology? What's your booth number?
So we are here at the EMO exhibition in hall number 12, booth number 12. Very easy to remember. And we're here also for tomorrow, so would be love to have anybody here who has interest in this kind of technology, and we would be happy to show everything even more in detail than just in this short discussion.
Thank you, Tobias, and don't miss out this booth. You really, really have to come and see all this technology.
Thank you very much.